Hello everyone. Hope everyone is doing well. Today we're going to learn about how to test the differences in proportions. We have done in my other videos some examples of that. In this case, we are going to use a different method of testing the equality of two proportions. We're going to use the chi-squared test. We are going to test, so our null here will be the proportion of one population equals to the proportion of the other. And the alternate is the proportions are not equal. So we're going to start with this one, and then in another example, we will see if multiple proportions are equal to each other or not. So in the null, later we will look at this. In the null, all the proportions will be equal, and the alternate is at least one of them is not equal to the others. Now let's look at an example. So let's say we have this data. We are looking at two schools, and we are testing if the students who are taking AP courses in school 1 equals to the proportion of students taking AP courses in school 2. So what are the steps for this? The first step is we have to find the pooled values. So what that means is that, what if we assume that these two schools were basically one school? So then my total would be the number of students taking AP courses would be this number, and the number of students not taking AP courses would be, copy the formula so that it stays as sum. And so once we have that, we should also total the total number of students in each school. So it should be, so we have in total 590 students. And if instead of school 1 and school 2, we had one whole school, then we would have 590 students. Now from here, we can calculate the pooled proportion. So the pooled proportion, so I would say then in the pooled, so in that case, my yes would be 0.76. So if we had one big school, then we would say that the proportion of students taking AP courses is about 76%. What we will find is what we call as the expected values. These are my actual values. These are what I found in the survey. But now, because this is my proportion here, and we calculated the proportion and it's 0.76, so for the pooled values, we're going to say, what if this proportion was applicable to both the schools? So in this case, we would say then, for the yes and no values, we are going to call it expected for school 1 and expected for school. So that is, it's saying that if both schools had the same proportion as the pooled proportion, then what would be the values for those? And so for this, we also need the no value, which would just be equal to 1 minus the other value. So now if I were to find that proportion, what I would do is just take 260, which is the value, the total number of students that are in school 1, times how many students said yes. And I'll click enter. So instead, the actual value is 200, but the expected value based on the pooled proportion is 198.30. And because we're using the same B8, what I can do is I can pull this as constant, and then I can just pull it down here. And so instead of 60, which is the actual value, the expected value is 61.69. For the second school, we would do the same thing. We have 330 students, and if 76% did that, it would have been 251 students who took the course versus, and then for no would be 78. So what I did for these two, I'm just going to write the formula right next to it. So now we calculated the expected values for those two schools. Now, just to make it easier, let us just write the formulas down here. So what we will have now is we have to now calculate how far is the actual values from the expected values. So we are going to calculate like a proportion. So in this case, what we will do is, if this is my actual values, let's call it A, and those are my expected values, we are going to calculate A minus E. Then we are going to square it and then divide that by the expected values. where actual values, I'm calling them as A, and expected values, I'm calling them as E. So we're going to calculate how far are each of these values, the expected values, away from the actual values. All the other things stays the same for yes, no, school 1, school 2. So we are going to calculate equals to. The first one, it doesn't really matter because, we are going to, the ordering doesn't matter because we are going to square it anyway. So the negative values will be positive, and if it's positive, it will remain as positive. And then we are going to divide it by the expected values. And we will do that for all of them. So I'm just going to drag it and copy the formulas. So one of the formulas, the formula for this one is that. And you can take a look at how we calculate it. So after we find the pool proportions and we did our expected values and we found the deviation of the expected values from the actual values, now we're going to total all these values. So we get 0.10915. This is what we are going to test against. So this is our test statistic. We just calculated our test statistic. And now we are going to look at a table for what we will call chi-squared tables. Chi-squared is very similar to the other tables we have used. So we have to find the critical value based on a certain degrees of freedom. The degrees of freedom will be equals to the number of schools, or -1, times number of options, -1. So the number of schools we have, currently we have 2 schools, so number of schools is 2, and number of options is yes or no. So that is also going to be 2. So my degrees of freedom will be 1. So which equals to just 1. So what we need to do now is find the chi-squared statistics. To find that, we're going to use a right tail value. So we're going to use the critical value as. The critical value will be chi-squared dot INV. We're going to use the right tail, and the probability is 0.05. In this case, we are not dividing it by 2. And the degrees of freedom will be 2 minus 1 times 2 minus 1, which we find is to be 1. And here I'm adding 0.05 because I'm just assuming it's at 95%. So let me write this up here. Assume alpha equals 0.05. So this is my critical value, and my test statistics is 0.01, so it's less than the critical value, so we do not reject the null. And that's how we do our analysis. We can also take this test statistics and find the p-value, and if we wanted to find the p-value, we would do equals to chi-squared dot dis dot rt. The x would be the test statistics up here, and the degrees of freedom that we calculated is 1. And we get 0.74, so of course it is greater than 0.05, so we do not reject the null. Now this is a case when we have 2 values. What if we have, let's say, 4 schools? So we added, let's say, 2 more schools to this. So in this case, we would have some differences in our values. So now we have all these other values. So now we have 4 schools and we have these values. So we would do the same thing as before. We have all these expected values. But before that, we need to first find the pooled value. So the pooled value for us is going to be just whatever total we have. Now, in our case, for the 4 schools we have, the total is 700 who took the AP courses in total, and 200 who did not take the AP courses in total. Proportion yes would be 700 divided by 900, which comes up to be 0.77. And the proportion that's no is just 1 minus 0.77, so that stays the same. The formula is, I'll just update the formula. So that we have here. Now the expected values are going to change because our proportions have changed to 0.77. So now what we will do is we're going to just update this value. So it's going to be times L. Actually, it was fine. It's L6. So those numbers are fine. This number is also okay. We need to delete these, and we need to do. So now we have our expected values. We just calculated them. The school 4's actual and expected values are the same because the proportion of school 4 and of the total are equal to each other. Now we do the same thing here. We have to find the expected A minus E squared over E for all those schools. So we have these formulas. These did not change. So what we need to do is just copy the formulas across and we get the numbers. So our numbers are that, and now we need the test statistics, which would be the sum of all these numbers right here. So we get 2.96 as our test statistic. Now let me just write this next to that so we know what we are doing. And we're going to use the same chi-squared table to find that. We just need to update our degrees of freedom. In this case, the number of schools is now going to be 4 minus 1, and we still have two options, so it's still that. So it would be 3 times 1, so we get it as. Now we have to find the critical value, so it would be chi squared dot inv dot rt. Let's say our alpha is 0.05 and our degrees of freedom, let me see if I can use this. I cannot use that, so I have to actually type it out. So I get 7.81. And since now we can also see that the test statistic is less than the critical value, so we do not reject the null. We can also find the p-value. The p-value is given here. This is my test statistic. I just need to update my degrees of freedom. Before it was 1, now it needs to be 3. So I'll just write 3 here. And this is my p-value. And I can say that based on this, comparing this p-value with the alpha, I can see that the p-value is greater than alpha, so we do not reject the null. So just a recap of what we did, if this was the actual values that was given to us, the first thing we will do is find the total of yes and no, assuming that all these 4 schools were one school. And so once we find the pooled values, we are going to find the pooled proportion, which is going to be 700 divided by 900 and 200 divided by 900. So the numbers are here and the formulas are there. After we find that, we then use the pooled proportion to find the expected values. So instead of 200, if the proportion was the same across all the schools, this is what I would expect the values to be. After we find these expected values, we then use this formula to find the percentage or the deviation of the actual values from the expected values. So we take each school's actual value, subtract it from the expected value, square it, and then divide it by the expected value. So these are the numbers we get, and after we get those numbers, we then add them together and we find the test statistic. We also calculate the degrees of freedom for our chi-squared table, which was the number of unique entities we have minus 1 times the number of options we have, which is yes or no, times minus 1. So once we do that, we then find we need to compare our test statistic with the critical value. We calculate the chi-squared critical value, which is given what alpha we have and the degrees of freedom, we get a number. We then compare our critical value with the test statistic, and then we decide whether we reject the null or not. We can also find the p-value down here. This is the formula to find the p-value. We use the test statistic and the degrees of freedom to find the p-value. And we also do the same idea. We compare the p-value with the alpha. If p-value is greater than alpha, we do not reject the null. Hope this was helpful, and I will see you at a later video. Have a good day. Goodbye.